A solid diprotic acid has an unknown molar mass. Student weighs out 0.647 grams of the acid, dissolves it in 50 milliliters of water, and titrates it with a 0.235 molar sodium hydroxide solution. Requires 37.45 milliliters of the base for the neutralization reaction to go to completion. What is the molar mass of the diprotic acid? Now the key here in this problem, this is another neutralization reaction with the titration, so the stoichiometry is going to be the same. However, what are we looking for? Molar mass is what we're looking for. The key here, what are the units for molar mass? Grams per mole. So we want this to be the units for our answer. We're starting with the usual acid and base. Our sodium hydroxide is our strong base, and our weak acid, diprotic acid, H2A, a generic formula. So first thing we want to do is start by writing the balanced chemical equation. So let's do that. We have H2A aqueous, and we're going to react that with NaOH aqueous, and our products are going to be Na2A aqueous plus H2O liquid, and of course we need to balance the equation. So with the two sodiums now on the product side, I need a 2 in front of the sodium hydroxide on the reactant side. 2 plus 2 is 4 hydrogens. I need 4 on the oops, wrong number. We're going to put a 2 in front of that water, not a 4. So now we have a balanced chemical equation. Now we can look at the stoichiometry. What are we told here? Let's look at our sodium hydroxide because we have all the information on that. We're told that we have a 0.235 molar solution of our sodium hydroxide, and the titration required 37.45 milliliters. Once again, we see we've got molarity, we got volume, multiplying them together is going to give us moles. Once we have moles of sodium hydroxide, we can convert to moles of our acid. And then what are we looking for? We're looking for the molar mass grams per mole. So we're going to make a conversion there. We're given grams in the problem. Please note that right here, I'm going to yellow highlight it. We're told how many grams we weighed out in the laboratory. So we already know that number, numerator. So let's go ahead and start working this problem. In our usual way, we're going to start out with the volume of the base that we use, and let's convert that to liters. So we're going to divide that by 1,000. So my starting point is going to be 0.03745 liters of sodium hydroxide. And now to get moles, we're going to multiply that by the concentration, which is 0.235 moles per liter. So we've got 0.235 moles sodium hydroxide per liter. Liters cancel. I've got moles of sodium hydroxide. Now I need to convert that to moles of my diprotic acid. Please note that we lost our coefficient here. We did have a 2 there. I don't know why it went away. 2 moles of sodium hydroxide needs 1 mole of the diprotic acid. So I'm going to multiply this by 1 mole of H2A for every 2 moles of sodium hydroxide. Moles of sodium hydroxide cancel. I now have moles of our diprotic acid. We're going to do the calculation here because please note we want grams per mole, and as I already mentioned, we have that number. But that's got to go in the numerator. So right now our answer is going to be a numerator because that's the way the calculation is set up. So let's go ahead and calculate moles of H2A. And when we do the math on that, we get a value of 0.00440 moles of H2A. So that's going to be our denominator. So we're looking for the molar mass. So let's write out our equation here. Our molar mass is grams per mole. Now we just calculated moles right here. Let's highlight the number. So that's our denominator. So let's put that number in downstairs first. Doesn't matter the order. we have 0.00440 moles. Now the grams upstairs is what was weighed out in the problem. So let's go back to the beginning, and we're told it's highlighted 0.647 grams of the acid. So let's scroll down and put that in. So we have 0.647 grams. Now we do the math, we get a value of 147 grams per mole. And there's our answer, molar mass. We have three significant figures as asked for in the problem, and right here is the number with the three significant figures in our calculations. So we're done.